we'll have a look then. Where are you hiding? 11, 5, 13, right?
Yeah.
Is that alternating series?
Yes. Finishing up the homework on that.
It's just been really slow again today. It's almost there. Okay, it looks like you're about 2/3 of the way through.
Yeah. So it's number 13.
Gotcha. Okay, so the guy that we are looking at is is it absolutely convergent, right?
So I can tell that it's there was no alternating series on it.
Right, you've chosen the answer that it's divergent, which we know is wrong.
Yeah.
So let me try. Did you know that it was some type of convergence?
After looking at it, it does look convergent because it's always going to be getting smaller and smaller. But it doesn't seem.
Yeah, but unfortunately, so the ones that diverge can do that too. So that on itself isn't quite enough. This guy is going to be absolutely convergent, right? So I guess what we have to do here is we have to look at what does the untouched version looks like and prove that it's convergent. And then we look at what would it be if you made all the terms positive, right? Agreed?
Yeah.
Now, I'm going to argue that if we were going to do it as is, that I can use a guy that we can, which is basically the comparison test, right? And I know I'm going to have to use it because that's sine thing, right?
All
Now,
right.
this guy behaves essentially as 1/8 of the 6 does, right? It behaves as a p-series. So I should be able to prove that this is less than or equal to 11 over n to the 6. Why can I say that for sure?
Because the sign it'll never get greater than 11
right,
on the top.
So 3 and 8 and 3 is 11, right? Now, we know this is a p-series, don't we?
Yeah.
And we know that it's a p-series with p equals 6, which because 6 is greater than 1 means that it converges. So far, so good.
Yep.
Now, if I wanted to make sure that this was all positive, wouldn't I have to stick this fella with an absolute round it?
Oh, an absolute, I see.
And I can also tell you that that is still true. And I can then say the same thing that I said here. So it's convergent when these are allowed to be pluses and minuses. It's convergent when you make everybody plus. And a series that is convergent when it's untouched and when everybody is made positive is called an absolutely convergent series.
So I started off by doing the 3 steps first, by showing it's greater than 0.
You were trying to do an alternating series test in this. This is not an alternating series.
Oh, so if I see something that doesn't look like an alternating series, I don't.
It probably isn't.
All right.
Right. If it's going to be an alternating series, they almost all have -1 to the n, -1 to the n plus 1. I guess the only weird one would be a cosine n pi, which actually generates the same thing, but that's maybe an exception. So if it ain't got a -1 to the n, you can assume that it's not. So you don't you don't treat something as an alternating series just because it's in a group of questions where everybody else is, right?
Yeah.
Each one gets treated according to what it is.
All right. I think that helps because when I took the derivative of it, I got a positive on the top and bottom, which meant that it was
Well,
decreasing.
not really, because the cosine of n will sometimes be positive and sometimes be negative. Because the cosine of 10 might be positive, but
That's
the
true.
cosine of 11 might be negative. The thing is, you won't really be able to standardize it because you have to prove it's always negative, and it won't be. And
Yeah.
that should have been a clue that the alternating series test couldn't be used.
It just occurred to me that the cosine could change.
Okay, right.
Wait.
So you good?
Yeah, I think so. Well, thank you.
Okay, not a problem.
See you next week.
See you next week. Oh, before you go,
Oh,
do
yeah.
you mind if I keep this and put it on the canvas so that people who might have a problem with this question?
Oh, yeah, that's fine. Yeah.
Right, so this was question 13, and it was from section 11.5, was it?
Yeah.
Right. Okay. So you're going to be famous. Well, maybe
only for
not
the
famous.
quarter.
Only for the quarter. Then nobody will see it again. You're right.
Okay. Have a good weekend.
Bye-bye.
Bye-bye.
You have a great weekend.
Hello.
Have you? What's your question?
11-5, question 11 and 15 and 18. I need help.
11, 15, and 18. And if I got you correctly, that's going to be from section 11.5.
Yes.
Okay, so I'm going to go and I'll find your specific one. That way we're going to be working with the numbers that you were working with. And here we go. Gotcha. So question 11, we'll start with that one first then.
I know that I finished it, but I know that I have done the limit testing before, but I want to do it again because I might forgot about it.
Okay, so question 11 is asking us what type of convergence this particular alternating series has, right?
Yes.
Which is that one. Great.
Yes.
So first thing I'm going to do is look at this guy because he's the only guy that really matters. And I'm going to rewrite it like that. Okay?
Yes.
So is this positive? Definitely. I mean,
Indeed.
1 over that, right? As long as n is greater than or equal to 1, won't this expression be positive?
Yes.
Now, next thing I'm going to do is prove that it's decreasing. Now, if you take this fella and you prove he's decreasing, what you do is you differentiate him. So I'm going to rewrite him like that to make the differentiation easier. So you multiply by the power, and then you reduce the power by 1. And then you make it look pretty, style points.
Top is decreasing, bottom is increasing over time.
Well, I would do it as positives and negatives, which is safer. The top is a negative number, so that's -8. 9 is a positive number, and the nth root of n to the 17 is positive as long as n is greater than or equal to 1. So a fraction that's made up of a negative with 2 positives on the bottom is always going to come out as a negative answer, and negative derivatives mean decreasing.
Alrighty then.
And that's the best way to prove something's decreasing, is to show that its derivative is negative. So we now need to do our our final step. And our final step is we need to prove or find what the limit of this guy is.
I just brute force it, or am
Yeah,
I missing something?
now you brute force it.
And infinity over anything is still infinity. Even,
Well, infinity, 1 over infinity is still 0.
no, but infinity to everything is still infinity, though.
As long as it's a positive power, yes. But infinity to the power of -1 isn't.
Euro, which
Infinity to the power of -1 is 1 over infinity, and that's 0.
which it converged, right?
But it converges, yes, it converges to 0, the limit. And so the whole thing converges. Now, all we've done so far is we've proved that the untouched version,
It's
which was
converging.
this guy, converges. Now, to test for absolute convergence, you take the series and you make it positive, which in our case just means removing the -1 part. And we have this fella. Right?
Yes.
And this fella could be written as this guy. This guy's dead easy. You don't need to do an alternating series test. Would you agree this is a P series?
Yes. P series of, let's say, 8 over 9. That is like less than 1.
And what does that mean?
Checking.
If you're less than 1, do you converge or do you diverge?
I remember that if it actually is let's see, P is less than 1, then that it diverge, because I remember
Yep.
that the other way around, which is bigger than 1, then it converge.
Correct. Now, when you have a series that converges, but when you make everybody positive, that new series diverges, those kinds of series are called conditionally
Convergent, right?
convergent. And so you would be picking the one that you picked, which was the second dot, and that's exactly the answer. Now this is the reasoning and the proof behind why that is the correct answer.
All right.
Okay, so that's that one done. Okay.
Go on to number 15.
On to 15. Okay. Now in question 15, we are looking at.
Really ugly now.
It is really ugly until you find that there's a little trick. Do you know what the cosine of n pi is actually equal to? Well, when n is 1, it's the cosine of pi, which is -1. When n equals 2, it's the cosine of 2 pi, that's +1. So this guy here is actually just a disguised version of that one.
Wonder that.
That's sneaky, right?
Yes.
So it is an alternating series now. In fact, you can see it's an alternating series, where here you couldn't really see it was an alternating series, but it is. Now, if you're looking at that series, right, you'd go through the alternating series test, right? So you would start with this fella here. And you'd say, yep, he's positive. That's pretty obvious. If you differentiate it, you might want to call it 6n plus 90 -1. If you differentiate it, we'll be able to prove in a few moments that it's decreasing.
Yes, it is actually decreasing.
And that's good, because a negative on the top and a positive number is negative. So we now know it's decreasing. And the last piece of the puzzle is that we find out what would the limit as n tends to infinity. And if you do brute force on this one, you get 0. So that means that this fella, this alternating series, converges. Did a kind of shortcut version of that one, but right, it's positive, its derivative is negative, which means it's decreasing, and its limit is 0. If you have a series that does this, that series converges.
Yes.
Right. Now, if you take this guy and you make them all positive, it's better to think of it as this guy. If you make them all positive, you end up with this fella. This guy here. And so now we have to figure out whether this guy converges, in which case the whole thing is absolutely convergent, or does this guy diverge, in which case the whole thing is conditionally convergent. This is not an alternating series test, right?
That's like a normal one.
Okay, so how would we solve it?
Do I just brute force it?
Brute force doesn't work, because all brute force tells me is that the individual terms go 0, but that doesn't prove a series converges, because if you brute force that one, these terms all equal 0, but that's a divergent. And if you brute force this one, these terms all go to 0, but that's a convergent. You see, you get no information by doing a brute force to the individual terms. That is not the method you're going to use. So which of the methods that we've learned over the last 2 weeks would you use to check if this converges?
What about the limit comparison test?
Okay, and if you're going to do a limit comparison test, wouldn't you compare it to 1 over n?
I was actually consider with 1/6n.
Nothing wrong with 1 over 6n, it also works. So that's a p series. And it has p equals 1. And that is divergent.
Which, yes.
We still have some work to prove that it's divergent, because maybe we picked a wrong comparison and we don't know if we have until we do the check. But
So is that the an over bn, right?
Correct. So we do an an over bn. So we have this guy over that guy. Which ends up being that guy. And the answer ends up being 1/6 if you use L'Hopital. And since this is a number, the limit comparison test says that your guy behaves the same way this does. Since this one diverges, yours diverges. So what we have is that the original converged. Right? This guy converged. But when you make everybody positive, it diverges. So what kind of situation do you get? Well, when that happens.
I got one from the an over bn process.
Yes, and 1 is okay. And 42 is okay, and minus 50 is okay. Well, not minus, because you'll never get minus, but 1/50th is okay, because this just needs to be a number. It doesn't need to be any specific number. Just don't be 0 or infinity. That's the only thing it's not allowed to be.
So if it's actually numbers, then it is divergent, right?
Not, well, in this case, yes, but only because of what you're comparing it to. If I was comparing this to a 1 over n squared and I got this answer, wouldn't that make this series convergent?
Yes, in the normal circumstance, but in p series circumstance, that actually.
So in this case, it does mean because I've got a number that's divergent, but the way you phrased it might not have been what you meant. But what I heard was, oh, if you always get a number here, right? If you do an over bn and you get a number, it means it diverges. That's not what it means. If you get a number, it means it behaves the same way this does, right? So if this one diverges, so will your answer if you get a number. If this one converges and you get a number, so will yours. That's a better way of phrasing it.
I see it now. All right.
So that's going to be conditionally convergent as well. So what's the next number in our list?
It's 18. I actually figured out that, well, I tried to solve it out, but the number behind it doesn't seem to be happy with it.
Oh, well, I'm looking at your answer. You're darn close. So I wonder if it's rounding off that's causing issues.
Because
So
I figure out that let's see.
how many
I think
terms do you need?
I figure out that I have 5 term and just needs to, wait, hold on. So a to the 5 and then translate to s to the 4.
Correct.
But I don't actually sure because each calculator I use, each different type I use, always end up with a different number.
Okay, so I'm going to do it on the TI-84. Now, right, and we're going to go through it and I'll hit the buttons and I'll see if it matches up with what WebAssign does. Because see, WebAssign might be using a computer program and computer programs very often can work to a phenomenal high degree of accuracy. And what that can sometimes do is it can make your answer a little bit different from what a poor calculator like a TI-84 should do. Now, you've said it's S4, and if this doesn't work, then I'll check on the S4 thing. But if you plug in 1 here, you get -1 squared. So that makes it 1 is positive for the first one. Then
Yes.
it's going to be negative for the second one. Then positive for the third one. And finally, negative for the fourth one. Is that what you did as your calculation?
Yes. Any
Okay.
form that I chose in Desmos and TI-84, I tried 2 of them. I didn't get the right one. Like, well,
Well, let's continue then. 1
Right.
over 1 to the 5 is 1. Take away 1 divided by 2 to the power of 5, which is that guy. Plus 1 divided by 3 to the power of 5, which is that one. Take away 1 divided by 4 to the power of 5, which is the last one. And I'm hitting enter. And the number that I'm getting is 0.971.
9. Around
8 round off 9. Yeah. So 0.9719. Now that's not the answer that they've got, but it's darn close to it. They have 0.9721. So it looks like I am 0.0002 out, which isn't an awful lot. Agreed?
yes.
So I'm just want to treble check that we don't need S5, right? In case that's the answer that they were using, right? So since I've already got this number in front of me, if I did one more term, right, it would be add 1 divided by 2 to the power of 5. And
Should be 5 over to the power of 5.
oh, darn it. Yeah.
That's
Okay.
like 7522, which is, oh, hold on. That is actually almost correct. Well,
So 0.97522. We can argue about whether that's a 2 or a 1. I guess it depends on the accuracy. So it might be that they were using S5. So let's check it then. AN is 1 over n to the 5, right?
yes.
And we want it to be correct to 4 decimal places, which means that you need to solve that guy.
Right.
Okay. Which means that n to the 5
Oh, I
is
think
1.
that my solution has less than 1 0 in that. I think it caused that to go somewhere.
Right. So n is going to be the 5th root of this guy. Four decimal places. So let's figure that out. In brackets, 1 divided by 0.123, 4 zeros and a 5. Close the brackets. And to get a 5th root, it's a bit messy, but you do to the power of 1/5.
Let's see, 7.25 round
Right.
to the second.
So, right. So 7.2 is how many terms? So we call that 8 because you always round up to be safe. And that means you actually need to find S7. So S7. It's a lot in S7.
That's
It's
going to be a
going to
lot
be
of term.
a lot of times. 1 over 1 to the 5, take away 2 to the 5, add 3 to the 5, take away 4 to the 5, add 5 to the 5, take away 6 to the 5. Wow, add 7 to the 5. Now, it would not surprise me that if you did that, you would get 0.9721 when you round it off to 4 decimal places. Do you want us to try it just to convince it?
I'm on the process of getting all those term on my calculator.
Okay, I'll wait for you.
I got 9721.
That was a problem then. You didn't get 8 terms, and you, from what you said, is you just dropped to 0.
I think I missed a 0 on that
Yeah.
point.
So try and remember when it's 2 decimal places, right? So if they said I like the answer in 2 decimal places, you do 0.005, right? And if you want 4 decimal places, it's 0.00005. So those zeros there are how many that you need for any given accuracy that you want. You want 2, make that 2 zeros and a 5. If you want 4 decimal places, make that 4 zeros, right? Before you do your 5.
All right, then.
So
That's all.
that came out good?
Yes.
Then